Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Stronger in Unity by Kafka Farnham. And here are the rules. We have zipper lines where digits an equal distance from the dotted center of the lavender lines must sum to the digit in the center of that line. So for example, if this were say 3 and 2, this would have to be a 5 because the two digits that are equal distance away must sum up to the digit in the center. That's an example of how zipper lines work. We also have chaos construction lines, where for each grid, we need to divide the grid into 6 regions, each made of 6 orthogonally connected cells, such that each row, column, and 6-cell region contains the digits 1 to 6 exactly once each. So what is an orthogonally connected region? It's basically just a region where you can go from any cell in the region to any other cell in the region just by going through edges, all while staying within the region. So to get from here to here, you would go along this path, and you could stay within the region all while just going through edges. An example of a region does not fit the orthogonally connected is, if, for example, this, because to get from this cell to any other cell in the region, you have to go through a corner or you have to exit the region. And this also is not valid because even though they can get to each other by just going through edges for these cells, you cannot go to the other cells in the region just by going through edges while staying within the region. So that's an example of how chaos construction works. And this is 1 through 6. In the top grid, every cell of any given line must belong to the same region. So these 3 have to be in the same region. These 5 have to be in the same region. These 3 have to be in the same region, etc., etc. In the bottom grid, for each line, every cells that are the same distance from the dotted center of the line must belong to must belong to the same region, while cells at different distances belong to different regions, and the center must be in a distinct region by itself. So it must not be in a region that the other pairs of digits are in. So these two have to basically belong to the same region. These two must belong to a different region because they are a different distance away from the center. And the center itself must belong to a different region because it's essentially, the center is a distance of 0. So that's a different distance than all the other pairs. So basically on the zipper line, in the bottom grid, the cells must basically match different, if they're the same distance away from the center, if for every distance away from the center, they must be part of a different region. So, or must be part of essentially the same region. So cells that are 0 cells away must be in one region. Cells that are 1 cell away must be in one region by itself. And cells that are 2 cells away or more must be in the same region, but different from the other 1 and 0 cells away regions. And that's how chaos construction works in these cells. And finally, we have Latin square, where digits must be entered such that without their chaos construction borders, the two grids would show the same Latin square solution. That is, the same Sudoku solution as adhering to rows and columns requirements only. So basically, it just the numbers that appear in the top grid must be the same as the numbers that are in the bottom grid, and they have to appear 1 through 6 once each, right? And you don't pay attention to regions because the regions are going to be different across the grids. Supposedly, these grids, I should say, have multiple solutions which work. And it's really that you have to combine the two to be able to come up with one unique solution, right? So basically you have to have the solution matching digits. So this digit, if this digit was a 5, it has to be a 5 in the bottom grid too, right? So that's all you have in basically the for the Latin square rule set. Is that you have to have the digits 1 through 6 in every row and column. And in this particular puzzle, the cells in each position must match exactly. So, and those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. Every line must belong to the same region. So this is all one region here, which means this must be this part of the same region. So we'll mark that as pink. This is part of the same region, but it could be part of the same region as that. We don't know. We'll mark this as green for now, this as orange. So this has to be part of the same region. These are part of the same region, but it's different from this. These are part of the same region, but it's different from this. So these have to be a separate region. I guess we'll mark this as red, and it cannot be the same region as here. So this one we have borders. So we know these are borders. This is a border. This is a border. This is a border here. And this is a border here. So these two have to connect with this one. Otherwise, there's just no way it can go across and be part of the same region, right? It has to, this one connects, I mean, you can't go all the way around and get 6 cells to connect to there. So this has to be part of the same region as that, which means it's part of the same region as that. So we'll mark that as red. These have to be the same region, and you cannot go 6 across here, so this has to be the same region as that, so we'll mark that as yellow. Therefore, we have boundaries there. This is a separate region. We'll mark that as blue. Red could be either part of this or this. This is green, so this has to go this way to be, because it's not part, these are not part of the same region, so this must be red here. So we'll mark that as red. That's 1, 2, 3, 4, 5. This must be part of the same region as that. And so it's 6. So then this is 6. This is done here. We have 5 here. We have 3 there. This is all the same region. So these must add up to these. Well, we know this is 4 unique digits adding up to another digit here. So this must be 5 or 6. And this must be then because 5 or 6 because of that. Also, in this region, so this region's done. We know there's another 5 or 6 here, right? This must be, actually this could be 3, 5, or 6? Right. So if this is 5, this is 1, 2, 3, 4. Otherwise, if this is 6, this is 1, 5, 2, 4, which makes that 3. So if this is 5, this has to be 6 here. If this is 6, this has to be 3 there. So this is 3 or 6 here. Okay. So these have to be 1 through 5. Which means these are 1 through 5. This is a sum of 2 unique digits. Well, we already knew that. This is the sum of 2 unique digits, so it has to be 3, 4, 5, or 6 here. And 3, 4, 5, 6 here. This is 1 through 5. So every part of the zipper has to be 1 through 5, right? And because they are guaranteed to be in the same region in the top grid, they have to be 3 through 6 in the middle of the centered cell of the zipper line. Okay. So can this part connect not through this part here? 1, 2, 3, 4, 5, 6, but that would be 7, 8. So no, it has to connect through here. So this is orange here, which means this is a boundary this way. Red could be one here or one of these two. These could be part of these cells there. Huh. Okay. What else do we have? These are part of the same region. These are 1 through 5 also. So we know there's a 6 in one of these two cells. These are 4 distinct different cells also. That means where is this cell? So these two cells in this zipper line cannot be in row 4 here. So they're either 1, 2, or 3 here. This is in the same region. So this cell, A, has to be one of these two cells there. Because it cannot be here and cannot be here. This cell cannot be any of these, but it could be the same as that. Okay. So this is guaranteed to have 4 here. What about... So what else can go... So there has to be another region here, right? And so this red cannot go this way, because if it tried to go this way, this would be one... You would have 8 cells in one region, or 2 regions trying... One region trying to be 4 cells, and then this being 6. So red cannot go here, so therefore this is blocked. This has to be a completely separate region, so you have 6 at most here. You could have this being yellow, or it could be pink. So this could be yellow here, it could be pink. Orange cannot close this off. Orange can only be 2 more digits, so that if this is not yellow, this could be pink or it's orange here, right? Blue cannot be part of orange. Red is only one of these two. So what are the possibilities for these cells? So red can be either of those. Yellow, you have 3. So yellow cannot go essentially well, red is one of these. So yellow can't get to here, because that would be 6 already and then 7 if it gets to there. So yellow could be here. You could have a pink going this way too, though. Or I guess a blue. Well, let's mark it as pink. So red can only go to here. Yellow cannot go to here. If yellow goes here, then this is a region of 3 cells, which is not allowed. So yellow can go 1 here, but it can't go here. So either this is pink or this is blue. So these could be blue also, right? Because that would be 1, 2, 3, 4, 5, 6. That's possible. Can orange close this off? If orange goes here, 1, 2, 3, 4, 5. Yeah, you cannot. If orange goes this way, this would have to form a region by itself, which would be 6, but then yellow can't be large. So yellow has to either expand this way, here, or one of these two. So these could all be blue, or it could be, so we have potentially 1, 2, 3, 4, 5, 6 as pink. Orange could go here. Orange cannot go here. Orange could go here, maybe? No. Because then you'd have a 5-cell yellow region and this pink region there still. So orange cannot go here. Pink could be here. These could be pink or yellow. Or blue, technically, right? Okay. Um... Hmm. These are a pair that add up to this digit. Does that help? I'm not sure. So if we have a set here, okay, so say this was a set, then this would have to be 6 here. Oh, and could that work? I don't think so, right? So if we had a set of 6 here, this would have to be 6 here as a set, guaranteed. Then this would be a set of 5, but that's it, because it can't be part of orange, and because there would be too many cells, right? 1, 2, 3, 4, 5, 6, 7, 8, if it were part of orange. So these have to be different sets. So that's red. Red has to continue out here. This has, well, it doesn't have to be green. Well, it does have to be green. If this weren't green, green can go up to here, and this would be a different region, so it would have to extend out to here, but then the green region would be 5. So this must be green. Okay, red goes to here. Red cannot go here and here. It cannot go here and here, because then this cell wouldn't have a region, right? If it goes this, this, and this, then that cell doesn't have a region. If it goes here, here, that doesn't have a region. So it must be specifically these two, which means yellow has to go that way. Okay, and this is blue, I guess. So we have region borders here. This is too small to basically have a region that's different from this region here. So this, we're going to make this blue because yellow's here. So we have 4, 5, 6. This must be combination of yellow and blue. Yellow, yellow could go here. Blue, 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 maybe there. So we have one more blue. Green could go 2. So you could go 2, 2. Can you go any other one? Orange can be supposedly any of these. And obviously, so can you go, you can't go green, green, because that would block these two cells from having a region. So you can go green, 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 green. This could be blue here. You cannot have a blue here, because again, you have 2 blues in this set. You have 3 here. You can only have 1 more. And if you go blue there, that doesn't have a region. You can't go blue there for the same reasoning, so blue has to be one of these two then. Right? You can't go blue here. That would cut off this cell from having a region. You can't go blue here for the same reasoning. Can't blue here because these 3 cells would not have a region. So blue has to be one of these 3. And orange. So this is definitely orange. Interesting. Okay. Interesting. Hmm. Hmm. So that means one of these three must be A, but we don't know which. Hmm. Um. Huh. Okay. Hmm. Hmm. Um. These four are orange. So 1, 2, 3, 4, 5 would force this to be. It could be 6 here. When that would be 6 green. This would be blue. If this is blue, though, this has to be 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. Huh. Interesting. Um. Hmm. So the orange here either extends 2 this way or 2 this way. It cannot cut off this because then this would form a pink, and then yellow can't get that way because it'd be only 4 cells. Can't go here, same problem. This would force yellow to have 5 cells. Oh, well, no, it could be yellow. So yellow could do something. Oh, no, yellow cannot do something like that. Oh, but yellow could go down. Okay, so this could be yellow. Dang it. Okay. So what are the possibilities then for each of these regions? And we have to basically start eliminating those possibilities based off of the other grid because there are multiple solutions for both of these grids. So we're not going to be able to come up with just one solution for just by looking at the grid. So you have to look at them in pair, right? Let's just make sure we have all the different combinations, right? So this one is pretty easy, right? You have either green here, and then you have orange here, and then blue combining this. So, okay. Green can only be these 6 or these 6. Orange could be these 6, or this 6, or this 6, or this. Oh wait, no, green can be multiple ones then. Green can be this 6, or this 6. Orange can be these 6, 6 here, or 6 here. Blue can be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4. That's it from with that. It can also be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And those are the possibilities. Yellow can be these 6, these 6, or these 6. Hmm. Okay, so that looks valid. Um. Okay. Which one's the restrictive one here? Probably yellow. So yellow, the only okay, if you have a pink going this way, that means yellow has to be like this. Which means red is here, blue has to be this, orange has to be here. If yellow is not like this, how does that work? Huh. Interesting. Okay, let's clear all the ones that are multiple right now, and then just really go through it. So yellow is the most restrictive. So if yellow goes like that, you have to have red there. Blue has to be this way. Orange has to be here, and this must be pink. Everything else means yellow has... This cannot be a full region. Right? Because yellow can't block this. Because then there's too many cells here without a region. Right? Only one of these can go to red. 3 cells would not have a region. If yellow can't go like that either. It can't be 1, 2, 3. Can't be 1, 2... I guess yellow could go like that. Ooh. That is possible. Okay, so that was wrong. So yellow could actually go that way, and then red is here. If red is here, though, that's very... Okay, so yellow can do this as 6. Yellow can do this as 6. You could... Can you have a pink here? I don't think so, right? So if you have... Yeah, if you have yellow here, this must be essentially a full region. 3, 4, 5, 6. These are 4. So you have 6 here. You could have these 6 again. You could have orange going this way then. Dang it. So orange can go that way. Oh, okay. Well, that's because I didn't realize that yellow can go all the way here. Yeah. Okay. So you could have orange going that way. Okay, so this is much broader than I thought it was. Oof. Okay, let's just keep doing that. So orange can be going there, or blue could obviously go in there. What else can you have? If yellow is this way, you could have orange going here. You cannot have orange going here or here, because that would block these cells from having a region. But you could have orange going... Sorry, you could have orange going here. You can't have orange going here, because that would block one of these... 2 of these 3 cells from having a region. So orange cannot close off this. Orange cannot go like that. Orange can only go that way. So then pink could go down to here as a set of 6. Or it could be these 5. So if yellow goes this way, we're guaranteed a pink region here. If yellow goes this way, also, we're guaranteed a pink region here. I guess we should count this as just essentially the blue. Anything that's on the bottom line has to be blue, so that we can just always force this to be pink. So I think this could potentially be pink here, essentially. That would be easier, or clearer, I should say. So again, you have 6 yellow here. You would have to have another region here. So you could have 6 orange here, and this is the 6th extent of the pink. You could have just 6 pink here, then orange could go like that, or orange could go like that. These could be blue. Right, so blue could go like that. It could go like that. And that's pretty much it, right? I guess it could do something like that. And then you have, yeah, orange being like that. Yeah, that's possible. Hmm. Okay, so then what happens if if yellow does not go here? So say red was here. Well, if yellow doesn't go here, this could be red or blue, right? But this would also have to be red or blue. So yellow would necessarily have to block one of these two, so this would not form a region. So in that case, yellow would have to go this way. So yellow either goes here or it goes to one of these three. It has to go to all of these three. Interesting. And if it goes all of these three, this must be the orange. So then pink can go here and could go all the way to here. It cannot go this way because then it would block blue, but it could include this cell, so that could be part of pink. So we know blue is these two, so that's guaranteed. Um, hmm. Okay. Huh. Okay, so I think I've done I've done all the combinations of for the yellow, right? Because again, if yellow goes here and here, if it tries to go here by itself without going here, the problem is this blocks this off. This is 6 cells here, but then yellow... Wait, can yellow go down there? Yellow could go down here. Ooh. So you could do 6 that way. Yeah, okay, so yellow can go down there. Hmm. So you cannot... Can you go yellow here is kind of what I was thinking of. And I think the answer to that is no. Right, because you have 1, 2, 3, 4, 5. The problem is this would be 9 cells trying to fit in one region, or 5 cells trying to get out, and that's not... Five cells trying to form a region by itself, which is not possible. So yellow cannot go this way, but you could go yellow this way, and you have orange going that way. You can't go yellow this way, because then that would block this off, right? You'd have 10 cells trying to be in 1 or 2 regions, which is not allowed. But you could go yellow that way. In which case, this would be some sort of blue. One of these would be red. And then, yeah, again, pink would be this 6. Oof. Okay. So, broader than I thought it was. There's a lot more possible combinations. We know that 2 of these digits have to be there. Okay, so we'll mark this as Z, I guess. Z and Y. So I guess maybe we'll make this Y and this Z. Or maybe start with Z. Z and Y. This has to be a ZY pair. Here. So this is Y and Z. Which match these two. Uh, hmm. Let's see. Oh. If this is the same, if this is the region, this has to be the same as this digit there, right? This is the same as that because we have these match and this doesn't match. So then these would be these would be the same cell. That's still possible. Red matches only those two guaranteed. It could match here, potentially. Where is this in the red? Well, it could be here. Never mind. Yeah, these are all very different. So the question is, for some of these yellows, okay, maybe we can use this orange here. So if it's orange this way, that matches these four, potentially. Ooh. So if it's, let's say this is 6, then these 3 definitely match. What happens if it goes 6 here? Then this cell is the same as that cell. That's possible. Okay, what happens if we have this? This cell cannot be any of these. This cell cannot be any of these yellow. So if it goes, if we go down to here, this cell would have to be this cell here. So these two cells would be the same. Seems possible. If we had this as a set, then this cell would be the same as that one because it sees all of those. And then, well, this, it could be either one of these two. If it's going up here, it's one of those 3. Not too helpful. Overlap is here for the reds. That's it. Where is this cell in column 2? So it cannot be these two because of this grid. Cannot be these two because of this grid. So this cell must be either here or here. This cell must be here or here. That doesn't help us much. Where does this... Yeah. Okay. This has to be either 1 4 2 3, 1 5, or 2 4. So you can never have 1 and 2 be here. Because if this is 1, 2, that would mean this is a minimum 3 and 4, which never adds up to a digit from 1 through 6. So this cannot be 3 here. Okay. You could have 4 and 1, though. 4 with 1 and 3. Then this would force that to be 2, 4. Huh, so how would that work? So say this was 4, you had 1, 3 here. This would then be 2 and 4 to add up to 6. So that would be 3 there. This would be 1 and 5. This would be 1 and 3, so that would be 1 and 3. This would be 1 and 5, so that would be 5. This would be 1. This would have to be 2, so that would be 6. This could not be 3 or 4. It would be 5 or 6. No 1, 4 here. No 1, 2, 3, 4 here. This would be 5. Ah, and we'd have a contradiction. 5, 6, and 2 at most. So it cannot be 4 either. Okay, so maybe this is the strategy. So this can't be 4 either. So this is 5 or 6. Interesting. Hmm. This cell in red. Okay, so this digit in red cannot be any of these. It can only be one of these 3. And it cannot be here because it's part of Y. So this digit has to be either this one or this one, right? Red is going to be either here or here. This cell sees all of these cells, and it sees this cell from the top grid, which means that it cannot be here. It's one of these 2. So what if we don't make it that? If we don't make it that, then this has to be 5. This is 5. That makes this 1 and 5 to add up to 6. This is 3. This is 2 and 4. So this cannot be 1 and 4 adding up to 5 here. It must be 2 and 3. So this is 2. That's 3. This must be 2 and 4 adding up to 6. So this is 4. That's 2. This cannot be 3 or 5 here. There's no 5 in. This can't be 2 or 5. No 1, 2, 3. This can't be 5. So this is 4. This must add up to then 6, and then this has to be here. So that's a contradiction. So then it cannot be the same as this digit. This must be the same as that one. So this is guaranteed to be the same. So let's mark that as B. B and B. So this is also 5 or 6. Interesting. That means these 2 digits must add up to this. Can they be different than this cell here? So if they're different from this cell, then they're all 6. So you have 6. Okay, so then this cannot be 3 or 4. So you have, say, 6, 6, 6. This is 5. So there's no 3 here. If this were 1 and 4, that would eliminate all possibilities for this to add up to 6, because that would eliminate 1, 5, and 2, 4. So this would have to be 2, 3, which eliminates 2, 4 here. So it's 1 and 5. Therefore, this is 1 and 4 here. So that seems okay. This is not 3, not 3. So this is 2 or 3. This can't be 6. That means we need a 4 in one of these, which means 4 cannot be here. This is 1, that's 4. No 1 here, so no 5 here. This is 4, we have a 2. Wait. What? I don't know why I made that 2, 3. Anyways, one of these is 4, which makes this 1, which makes that 4. That eliminates 1 here, so no 5 there. So that seems kosher. One of these is a 4. We'd have to have 3 there. Okay. Again, no 6 here. This can't be 4. This is 1, 2, 3, and 5. So that seems okay. Hmm. Um. Hmm. What happens if this is 5? You have 5 here, 5 here. That means... I think that's a contradiction. This can't be 5. This is 1, 2, 3, 4. You have a guaranteed 6 here. You'd have a guaranteed 6 here, so this would be 5. Which makes this 6. I guess that... No, that does kind of work. So you'd have 1 through 4 here, 1 through 4 here. 1 through 4 here. So this is 5, which means this can't be 5 here. 6 would have to be one of these 3. So 5 could not be here. 5 could not be any of these. So 5 would have to be here. Oh, that's interesting. So then these would have to be different sets. 5 could not be here. So you'd have a 5 in one of those two, and a 5 in one of these two. So these would be different sets. So this could not be blue. It would have to be pink. Which means blue cannot go to here, because that would block pink off. So therefore this would have to be pink this way. And since that's the case, obviously yellow can't be here. That would force... If yellow cannot be here, because this would be too few cells. So therefore yellow cannot go here. This is blue and red as a combination. So then yellow has to be 3 this way. So this is not pink. This would not be pink, that's orange, which means none of these could be orange. This could not be yellow, it's pink. Blue has to be 1, 2, 3, 4, 5, and then 6. So that would be blue. No blue there, that's pink. So then 5 could not be here. 5 would have to be here. This would be 6 and 1. But we'd have a 5 here. And that would lead to a contradiction. So this cannot be 5. So then we have that. So this has to be 6. Okay, good to know. So we have 6 here, 6 here. These cannot add up to 6 here. That's 1 and 5. No 3 here. So we're guaranteed a 3 here. So these are 6s. This cannot be 6, which means this cannot be 5 here. No 6, no 5 there. 6 is one of these two in the pink. So it'd be tried 5 there, and that seemed to work out fine. 6 cannot be anywhere here in column 3 or here. So 6 has to be guaranteed one of these two, right? We have 1 through 5 here. This can't be 3, no 3 here, no 3 here, no 3 here. We are guaranteed a 3 here. So orange needs access to a 3. And it's either here, one of these 4. Interesting. Orange in the top grid, I should say. Huh. So 1 through 5, 1 through 5, 1 through 5. Again, this is Y, that's Z. So they have to match. Can this be Y? No. Because if this is Y... Oh, it could be Y. Never mind. This is basically when match one of those two. Never mind. It can do that. That's fine. That's perfectly fine. Yeah, no, that doesn't work. Obviously, if this is Z, then these two match. And that's fine. Or is it? That's interesting. These two match, then that means these can't be that cell, which means these matching must mean that must be the same. It's different if this is Y, I think, right? Okay, what happens if this is 6 now? So you have 6, this would be 3. So none of these could be 3 here. None of these could be 3, I should say. This becomes a 1, 2, 4, 5 triplet. We'd have a 3 guaranteed. 3 cannot be here. So you'd have 3 and 6. You'd have these two adding up to 6, these two adding up to 6. But this one could be the same. Okay. So then whatever cell's here cannot be here. It must be one of these two. So whatever cell's here must be one of these two. So this cell cannot be this cell, which means these are not the same. So Z has to be here. Y has to be here. So this cell matches, cannot be here because it's one of these two. This would obviously not be 3. We'd have to have a 6B here. So this would be 6, which means this cannot, or it could be pink. You could have a 3 there. Yellow would need access to a 6. So yellow could not be these 4. Or sorry, these 3 here. Oh. Wait, hold up. Oh, that's not true. This could be 6. Okay. So in this scenario, yellow cannot go here. Yellow has to go... It cannot go here it has to go here. So therefore, yellow could not be here. This is blue. Yellow has to be included here because it needs access to a 6. And because of that, this is yellow. This has to be both yellows. And this would not be pink. Well, we don't know that. This would be a yellow-blue combination. So this would not be pink. We guarantee this is yellow, and this could be yellow or blue. This would have to be orange. Oops. And this could not be orange. This would all have to be pink. Okay. So yellow could be here, or yellow is one of these. This could be red still. We know one of these is a 3. So we have 6, 6, 6, 6. 6 cannot be here. 6 would have to be here, and we'd have a contradiction. So we know this cannot be 6. This has to be 5. So this has to be 5, which forces this to be 6. Okay, oops. I didn't go far enough back. This is 5, this is 6. So 6 cannot be here anymore. This can't be 5 here. No 5 here. No 5 here. So this is 5, which makes this 6. We don't have access. We need a 5 in... Well, 5 could be there. Oops. Never mind. This cannot be 2 and 3, 1 and 4 adding up to 5 again, because then that would eliminate 6, 1, 5, and 2, 4 adding up to 6 here. So this must be 2 and 3, which makes this 1 and 4. So we have 2 and 3, 2 and 3, 1 and 4, 1 and 4. That forces us not to be 2 and 4, so it's 1 and 5. We have a guaranteed 4 then in one of these two cells. So no 5 here. We have a guaranteed... Okay, this cannot be 1. It's 2, 3, or 4. We have 2, 3, 4, 2, 3, 4. And 4 has to be one of these two cells. So this cannot be 4 here. It's 2 or 3. So we have 2, 3, or 4 here, with 4 being there. So this is 1. This is 4. That means this cannot be 4 here. So we have 1 and 4 there. No 4 here. We have a 4 guaranteed here. So 6 in row 5 has to be one of those two. This is guaranteed to be 4. We have 1, 4, and 6 here. Interesting. So it cannot be yellow this way, because if it's yellow this way, the problem is... Right, if it's yellow this way, the problem is yellow doesn't have a 5 to access. So this can't be 4 or 5. This is 1, 2, or 3. So this cannot be 3 yellows, which means this is pink. So we have 4 pinks here. Okay. 1 eliminates 1 here, which means this can't be 5. Okay. This is 2 or 3. No 1 here, no 5 here. So this is 4 pink, so this cannot be pink. So this is definitely blue. Well, okay. Yes. So then the problem becomes, if blue goes this way, then where are the 5s in columns 1 through 3. You can only have red 5 and green 5. And yellow can't be 5 there because blue has to be here. So this cannot be blue going this way, right? If it goes blue going this way, 5 can't be here. That means 5 in green has to be one of these two cells, which means this can't be 5. So where's 5 in column 1? It has to be here. So this is 5, this is 1. That eliminates 1 from being here. This is a 2-3 pair. So we have 5 here, this is 1. Obviously, these can't be 1 anymore. This can't be 5. 5 has to be one of these two. So no 1 here. No 1 here. Where's the 5 remaining in column 2? It has to be here. So this is 5. And this is 5. Which means this cannot be blue. So none of these could be blue. Which means this must be yellow, yellow, yellow. And this is red. So then this is boundary here. We have blue here. This is boundary here. Yellow obviously cannot be here. So you cannot go full pink because we have 3 pink here. So this can't be pink. That's blue. This can't be 4, obviously, because of 4 in the region. So 4 in red has to be here. So this is 4. This is not 4. This can't be 4. So this is 1 or 2, which is with 4, 5. We can remove these then. This is 2, 3 as a pair, which eliminates 2 and 3 in the rest of the box or column. So this is 4. This cannot be 2, 4 as a pair to add up to 5 then, because of that 4. So this is 5 and 1. This is 2 or 3, and this must be 2 or 3 also. So this becomes 1 and 5. This is 2, 3 as a pair. This is 2, 3 as a pair. That leaves this as 4 and is 4. So this Y maps to there. That's fine. This can't be 1, so we have a 2, 3 pair, which eliminates 2 and 3 in the rest of the row. This 1 eliminates 1 here. So this must be 1, 2, or 3. We have 1, 2, or 3 here. So this is A, which means this can't be A, so this must be A here. Let's just use the bottom set. So A's here, A's here. Where's A in column 1? It must be there. Therefore, this is B, B, and B. That means this is not 3. This is 4, 5. This can't be 1. 4 cannot be here. 4 is one of these two guaranteed. Since 4 is one of these two guaranteed, this cannot be 4. This is 5, which makes this 4. These are in the same region, so it cannot be 2 and 2. It must be 3 and 1, which eliminates 1 and 3 here. So this is 2, which makes this 3. So all the B's are 2, 3. All the A's are 2. So this is 2. This is a B also. And so we can make that 3. So then we have 1, 4, 5, 3, 2, 3, 2, 3, 2, 3, 2, 3. Okay. We have 3 and 6 remaining in row 5. So this is 6, this is 3. We have 6 and 3. Column 5 has 1 and 5. This can't be 5 because of 5 in the row. So this is 1, 5, 1, 5. We have 2, 6 remaining. And 2, 4 remaining. This can't be in row 2. This can't be 4, so that's 2 and 4. which means this can't be 2. That's 6 and 2. So that means this is 2 and 3. So this is guaranteed to have a 2 here, so this cannot be green. It's orange. Which means this can't be green. We have to have guaranteed green there. So that's done as a boundary. 3 cannot be with 3 here, so this is not blue. This is orange, which forces this to be blue. So this is boundary here. 3 cannot access 3 here, so this is not yellow, not blue, sorry. That's yellow, which means this has to be yellow. Otherwise, if this were yellow, that would be not. It would force this not to have a region. So then this is the boundaries there. 6 cannot be here, so this can't be blue, which means this can't be blue. So this is orange or pink. This is guaranteed to be blue here. That's done as a region. Pink cannot have 2 in the region, so this can't be pink. It's orange, so that makes this orange. So that means none of these are orange. This is pink. And we are done with the regions. And then we just need to fill everything in. This is, we have 6 and 2 there, which leads to, this is 4. That leads to 6 and 1, and 1 and 6. And that's a solution. Very cool. Very, very cool. Wasn't really sure how to approach this, but it seemed I mean, I guess you just tried. We did some trial and error, though, I guess. But that was interesting how it interacted between the two grids, right? So, very fascinating how those interactions worked, right? I'm not sure. Yeah, I'm not sure you can really logic through things without just trying it, right? Because it's going to be very difficult to keep all those numbers in mind. You just have to sort of like put a digit in a certain location, try it out, and then go, oh, this is a contradiction, right? And sometimes that's just what you got to do. There were some interesting little interactions though there between the sums. It was interesting. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.